Two scientists have now analysed all 112 PURSUE UFO videos, and the problem they found is so fundamental that in one case the release data can't even distinguish between a nearby bird and a distant object travelling at Mach 5. And that, I think, is far more interesting than simply asking whether any of these videos show a UFO, because the real question is, if we can't reliably establish something as basic as speed, what can these videos actually prove? There is one particularly useful comparison here as well. We've seen this problem before with the famous Go Fast video, except in that case there was enough information on screen to change our understanding of what we were looking at. A slightly different one today. Neil couldn't join me for our planned recording, so I'm flying solo again, which seems appropriate given that today we're mostly trying to work out how fast things are flying. On the 12th of August, researchers Haqq-Misra and Ravi Kopparapu published a scientific preprint examining the 112 sensor videos released under PURSUE, the Presidential Unsealing and Reporting System for UAP encounters. A preprint is the important wording here. The paper is publicly available scientific work, but it has not yet gone through peer review. So this isn't science has settled the Pentagon UFO videos, it's two researchers presenting an analysis that can now itself be checked and challenged. And what they did was surprisingly straightforward. They went through all 112 videos and asked, what information do we actually have if we want to calculate the physical velocity of the object? Not how fast it seems to move across your screen, how fast it is actually moving through the real world. Those are very different things. So imagine looking out of a train window. A fence post a few metres away flashes past almost instantly. A distant hill barely seems to move at all. Now the hill isn't travelling more slowly than the fence post. Neither of them is moving. What changes is the geometry between you, the object, and the background. Military sensor footage has the same problem, only with considerably more expensive acronyms. From a video, you can measure things such as how many pixels an object crosses in each frame, but to turn that into a real speed, you need more. You need to know the range, how far away the object is. You need the movement of the aircraft carrying the sensor. You need the angle between the object's movement and your line of sight. And you need to understand the camera's field of view or angular scale. Now, according to Haqq-Misra and Kopparapu, no video in the entire 112 video PURSUE collection contains the complete set. They divided the footage by how the objects behave on screen. 43 clips show an object transitioning across the field of view. 33 show an object being tracked, so the camera follows it and tries to keep it around the centre. Another 36 contain both behaviours. 79 clips contain one object, 33 contain multiple objects. But here's the crucial point. Even a tracked object sitting neatly in the middle of the screen tells you almost nothing about its speed from the pixels alone. The camera is moving specifically to cancel out its movement across the image. The video can look stable because the sensor is doing its job, not because the object is stationary. And then we get to DOW UAP PR113. This is footage released as an unresolved UAP report from the Western United States recorded in 1996. For a fraction of a second, a compact dark object tears diagonally across the image. The researchers measured it at about 142 pixels per frame, roughly 2.2 frame widths every second. And it is directly visible crossing the frame for only around a tenth of a second. That certainly looks fast. But PR113 has something almost none of the other footage gives us: visible angle markings burned into the image. The researchers interpret these as depression angle markings, and from their spacing they can estimate the camera's angular scale and reconstruct a field of view of roughly 54 degrees. So, now we know how quickly the line of sight is changing. Surely, now we can calculate the speed? No, because we still don't know the object's range. And this is where bird or Mach 5 stops sounding like a ridiculous thumbnail wording and becomes the entire point of the exercise. If the object is small and very close to the sensor, it can cross the image extremely rapidly whilst travelling at completely ordinary speed. Move that same apparent object farther away, and now it must be physically larger and travelling dramatically faster to produce the same movement across the frame. The researchers show that the available measurements are compatible with possibilities stretching from something bird-sized, passing nearby, to a large object much farther away travelling at supersonic speed. Their headline illustration includes a large craft around a kilometre away travelling at Mach 5. They are not saying it was a bird, and they are definitely not saying it was a Mach 5 craft. They are saying the video, as released, cannot tell us which sort of physical situation produced what we see. That distinction matters enormously. And there's another caution with PR113 as well. Arrow's own release notes say the media had been digitally altered before it was reported to the UAP task force, and that Arrow is presenting it as received. We aren't told in that description that the alteration created the object, and we shouldn't imply that. But it is another reminder that this is not pristine raw data arriving with a lovely folder containing everything a scientist might want. Now, compare that with PR149 recorded in the Middle East much more recently in 2023. Here, an object crosses the infrared image while the ship is also visible in the frame. That ship is useful because it gives the researchers something of approximately known physical size to use as scale reference. Using the ship, they estimate that if the object is at roughly the same distance from the sensor, its relative velocity has an upper limit of around Mach 0.3 to 0.4. In their analysis, supersonic relative velocity can be excluded for this case. Now that's far more informative than simply saying, well, it looks quick, but the identity of the object obviously isn't established still. Its exact range remains unknown, and therefore its size and precise velocity remain uncertain. So, one video from PURSUE can accommodate an enormous range of possible speeds. Another allows a useful upper limit. Neither on its own tells us exactly what the object is. Now that brings us back to the famous Go Fast video. The 2015 Navy footage became famous partly because the object appears to race over the ocean. But unlike the PURSUE clips in this new study, the display contained useful information: range to target, camera angles, aircraft altitude, speed and bank angle. Arrow's later analysis still couldn't calculate one perfect unquestionable speed because some information, including the aircraft's exact heading and location, was missing, but it had enough to model plausible solutions. Its conclusion was that the object was at around 13,000 feet, not skimming the sea, and that its apparent dramatic motion could be explained by motion parallax. Arrow assessed with high confidence that it showed no anomalous performance. You don't have to accept every Arrow judgment unquestioningly for the lesson to matter. More data changed what could reasonably be inferred from the video. And this is where I think the PURSUE paper becomes genuinely important. The government itself describes these released cases as unresolved and acknowledges that this can simply mean there isn't enough data. It has also explicitly invited private sector analysis. Well, this is private sector and scientific analysis, and one result of that analysis is effectively, thank you for the videos, now we need the measurements. I don't think that automatically makes the release meaningless, and I certainly don't think it demonstrates some sinister attempt to hide the truth. I'm sure plenty of people out there will fall on one side of that fence or the other. But remember, these are military systems. It's entirely reasonable to expect that public releases will not necessarily contain every piece of information associated with the original encounter. But the videos can still be useful. Researchers can study morphology, recurring sensor effects, how objects appear under different imaging systems, and perhaps most importantly, work out exactly what additional information future releases need to contain. But there is a big difference between transparency for viewing and transparency for analysis. Giving the public footage allows us to see what was recorded. Giving researchers sufficient data allows them to test claims about what it was doing. Those are not the same thing. Now, I think this cuts both ways in the UFO debate. If somebody looks at PR113 and says, that thing crosses the screen insanely quickly, therefore it must be displaying extraordinary technology, this paper gives us a very good reason to slow down. The speed has not been established. But if somebody else says, it could just be a bird, therefore it is a bird and the case is solved, they're making essentially the same mistake, just in the opposite direction. The bird is one possible solution permitted by the missing information, but it is not an identification. So, what did scientists find when they analysed 112 Pentagon UFO videos? Not aliens, sadly, not 112 debunks, and not proof of extraordinary aircraft. They found that the public videos in their present form generally cannot answer one of the first quantitative questions we naturally want to ask about them. How fast is that thing actually moving? To answer that properly, future releases would ideally include whatever can safely be provided from flight logs, sensor field of view and pointing information, range data or correlated radar tracks. And if some of the raw information genuinely cannot be released, perhaps the next question is whether independently checkable derived measurements can be. Because the most important thing this paper may have identified isn't what those objects are. It's what we cannot honestly claim to know about them from the videos alone. And for a subject in which, look how fast that thing moves has been doing an awful lot of evidential heavy lifting for a long time now, that seems worth paying attention to. So that brings us to our question of the week. When an official UAP video is released but the data needed to calculate the object's speed are missing, how much evidential weight do you think we should give the footage itself? Let me know in the comments below. And if you enjoy Aliens Explored approaching these cases by asking what the evidence actually allows us to say, please do like this video and subscribe. Neil and I will be back together again very soon, but in the meantime, keep watching the skies. Take care.